to JAX London. I'm here with Rob and Sumanas. Hey guys, how are you?
Hey,
Not
good,
bad,
thanks.
Yeah.
A lot of companies are experimenting with artificial intelligence nowadays, but some companies feel like they are being left out if they don't use artificial intelligence. So they feel the pressure to invest in an artificial intelligence strategy, although they might not fully understand what they want to achieve actually. So when is it wise to jump on the artificial intelligence bandwagon, and when should they stop?
Yeah, for sure. There's definitely a lot of pressure on companies at the moment. You've got companies like Google and Facebook who are really putting machine learning front and center of everything they do. The recent Google Made by Google event really was just talking about how machine learning is enabling all their products, and they're really playing up the future promise of the technology. I mean, we would advocate not jumping into it, rather taking a product-first approach. So if you have a product and you think it could be improved by machine learning, then you can start to investigate it and tentatively look at potential options into moving into the machine learning field. But we definitely advocate making sure you have an established product, or at least found product market fit for your product, before you start looking into machine learning. There's quite a lot of cost and risk associated with building up the whole machine learning team and infrastructure that you need to really get it to production. So we would suggest deferring that until you're really sure you're ready to do it.
And the analysis of Stack Overflow suggests that Python is the first choice in the field of machine learning. But although it's popular, is it really suitable, the most suitable programming language for machine learning?
Yeah, it's definitely a very popular language. The recent Spectrum ranking, obviously any programming language ranking is a bit of a dark art, but the recent Spectrum ranking had Python at the top, and it's been on an upward trajectory for the last couple of years. This is undoubtedly driven a bit by the wealth of machine learning libraries that are out there in Python.
Yeah, and to a large extent, I think one of the reasons why machine learning is, tending to have a Python flavor is because academics, they usually do their research in MATLAB or a similar scientific computing environment, and when they want to move to an industrial setting, a language like Java might be a little more intimidating, and Python is way more user-friendly, I think, to them, and that you have this natural trend of people just going to Python because it's the easy start with. All their colleagues have used Python, have spoken highly of it, and it just becomes like a social thing at that point. That's not to say it's a bad thing, it's just could be one reason why.
And what libraries do you prefer and why?
So I have a preference for Python myself. I did my thesis using Python. I used TensorFlow exclusively for my research, and I found it really interesting and fun to use. There were bits of it that had me scrambling through the source code trying to figure out what was going on, but no point did I really feel lost. That's not to say that the other languages are bad, it's just my own personal experience, and if someone else has more experience with Scala or Java or any other language, there are libraries and tools in the other languages, and they're encouraged to try them first before jumping on a buzzword language just because it's there.
And what are the steps in a machine learning pipeline?
So I'm going to try and be as abstract as possible because it's really up to the problem you're trying to solve with machine learning. So the first thing would be to try and identify what you're trying to solve with machine learning. It's not a good idea to just collect data and then try and find it. You should first identify a problem that you're trying to solve, and then once you've figured out that this is how we're going to measure the success, okay, this is the problem, this is what a solution might look like, you can go about then collecting data that would help you achieve that. Once you've got this data, you can think about encoding it or preparing it for a machine learning model. And oftentimes people spend very little time here. This is like the encoding level, and it's probably the most fundamental part. You could have a very powerful machine learning model, but if your embedding or encoding layer is not done properly, it's not going to give you a good result. And on the flip side, if you have a very good encoding and embedding layer or format, then even a simple model will give you very good results. So it's a crucial, fundamental part that needs good attention. And then once you've prepared the data and you've got it in, you choose a number of you try out a different number of machine learning algorithms. There's no real set solution that for this problem you need to try this. It's really up to a case of trial and error and looking at existing research and existing work to figure out what best suits your situation. And then once you've got there, you evaluate it using your previously identified problem set, and you move on from there.
And can we apply agile best practices to aspects of machine learning development?
Yeah, absolutely. Again, another thing that we advocate is very much just treating it like you would any other commercial engineering project. So clean code, agile sprints, proper planning, and all these things are really key to being successful if you're trying to do a commercial machine learning product.
And what are the challenges of applying agile best practices to machine learning development?
One of the big challenges is that it's different to a normal engineering task in as much that it is not such a clear right and wrong answer. It's not where you can set a particular solution and get a team to build it. There is a lot of research that naturally needs to be done, and a lot of that research will end up at dead ends and be stuff that's thrown away. So it's hard to plan, and it's hard to convince management of the value in this ongoing research. You might have months of sprints whereby your team is doing research, which might all end up being things that you never actually want to take to production. So it's hard to make a compelling case to the management to do that and to really sell it. But I think if you push through that, if you've got management who are very much on board with machine learning and the value that it can provide long term, then it can really work really well.
Last but not least, how can we use machine learning to our advantage, and what does the future hold for machine learning?
What the future holds is very interesting. I think, as I said at the start, with all the companies talking about it, I think it's just going to become more and more pervasive. And all the products we use every day, I think more and more they will start to have machine learning in them as just part and parcel of what they do, enabling all sorts of things from instant translation, being able to just point your phone at anything or any sound or anything and just get loads of information about it, as well as all the stuff around self-driving cars and all that kind of cool futuristic stuff there.
Yeah. So one of the interesting things about machine learning is that it encourages us to think about problems that previously we might not have considered, and as solutions to problems in a similar way that we may not have always thought of. I don't know if it's a good one. I think it's a really nice example is if you wanted to have a little app that would tell you when to water your plants. You've got a potted plant at home and you want to know the optimum time to water it. You might traditionally go around a route of sticking sensors in the plant, in the soil, monitoring the gases it gives off. There's all sorts of different ways that we would approach this problem right now. What machine learning tends to do is it tries to encourage us to think in a different way. So we can go and say, all right, what if I had an app where I would just take a photograph of the plant and it would just tell me, how many hours I have to water the plant. And it would just be vision-based. So this is a machine learning or a computer vision-based task. It doesn't have to be that way. You can use the sensors with machine learning or without them. There's a myriad different approaches that suddenly open up for exploration. It's not to say that this is going to work, but we suddenly have way more avenues of exploration available to us because of machine learning.
That sounds great.
Yeah.
Thank you very much
Thanks.
for the interview, and
Thank you.
enjoy the rest of the conference.
Thank you.
Awesome, thank you very much.
Thanks.